As of today's session, we will be discussing VRF. Here, so VRF is virtual routing and forwarding. Yeah. So the first thing, let me think I'm an ISP, and I have got two plans. Right. So here, this must be their branch 1, and this is their branch branch. Right. So being ISP, I have got some requirement, that is whatever the routes that are given by, or let me name these companies. For example, this is
Airtel,
TCS, and let me go this for BT. Right, and there is also the TCS, and here BT. Right. So the requirement is this is how I am connected. And now I need to provide end-to-end VPN. Clear? So VPN, which means that they are extending their private networks. Now TCS is extending their private network from branch 1 to branch 2 and even BT. Right? Okay, there is no problem till here. Yeah, but let me think that TCS is using 192.168.1.0/24 and BT is using 192.168.2.0/24. Even in this, I don't have any problem. He is using branch 1, TCS is using some network and BT is using some other network. They are completely different networks, so I don't have any problem. Right? But the thing is, what if even BT uses the same network? 1.0/24. I cannot tell, being ISP, I cannot tell BT or TCS to change their internal network. Right? So after the deployment of their network in their branches, they have come to me to extend their for the extension of their network, and now I cannot tell them to change their networks. Right? Now I'm receiving the networks from TCS and also from the BT. Yeah. So by default, I will store this information, routing information, in global routing table, which is my routing table. And the same thing here. Now, when branch 1 of TCS needs to speak or communicate with their branch 2. Here, how can I make sure that branch 1 or TCS traffic is moving through me and it reaches the same branch same TCS branch office. Both are using the same network. Yeah, bro. Somehow they are using the same network, and I want to differentiate them throughout me. I have to make sure that their data is not getting into another company. Okay. So in order to do that, what do we do? Okay. So in this case, if let me think that this particular ISP router 2 has two equal cost. I mean, now this branch 2 network and even branch 2 network of both TCS and BT, they are at equal cost from this particular router. Now this from this here, a PC has generated the traffic 192.168.1.1. This will speak with 192.168.10.10, which is in branch 2. Right? And even here, let us think they are using the same network 192.168.10.0, and here also it is 10.0. Now, being an ISP router, I am receiving information from both offices, TCS and BT. As they are at equal cost from me, whatever the traffic I am receiving from this particular TCS PC, that will be received by me. But as I am storing this information in my global routing table, I will just load balance. Right there, I have learned them via whatever the protocol. I'm load balancing. That means half the traffic goes to TCS and half the traffic goes to BT. Where this half traffic is not allowed to go to the BT, but I'm still sending it to BT. Right? Not the thing need to happen. Right? What do we mean by confidentiality? We told that being a VP, providing the VPN service, we need to provide the confidentiality. We need to provide the integrity, everything. But at the very first one, we are losing confidentiality. Packets of one company are entering into another company router. Clear? So in order to do this, whatever the packets, whatever the thing, in order to keep them separate, if I do save them in my global routing table, I cannot do that. I need to differentiate them. This is TCS traffic and this is BT traffic, and these are TCS routes and this is BT routes. How do I differentiate them? Right? So in order to do that, Cisco has come up with a concept called VRF, which is virtual routing and forwarding. Okay. In simple, VRF is creating multiple routing tables. Creating multiple routing tables and assigning each routing table to each client. Right? When I do this, whatever the traffic that I am receiving for one routing table, that will not enter into another routing table. Everything will be kept separate. Clear, guys? Getting it? So first, what virtual routing and forwarding is, I am creating multiple routing tables and I assign each routing table to each client. And the rule is routing information of one routing table will not enter into another routing table. And this way I keep them separate. Right? So here what will I do is in this case, I will create a separate routing table for TCS and I will create a separate routing table for BT. And I will extend this information throughout my ISP routers, where each and every ISP router will know that there is a dedicated routing table for TCS, and whenever they receive the traffic from TCS, they will forward it according to the TCS routing table. And here R2 knows that it has a separate routing table for TCS, so it will only check the TCS routing table, and TCS routing table is pointing to this through this interface, so it will forward the traffic via this interface.
और सर किस बेसिस पे डिफरेंशिएट करेगा सर?
That will do it. That will see it. Right? Everything goes on basis of interfaces. Okay, I'll differentiate. First, I'll create VRFs, and I will make interfaces part of them. And with that, that's it. I will have multiple routing tables.
सर इस तरह से तो राउटर का प्रोसेसिंग बहुत ज्यादा बढ़ जाएगा आईएसपी के राउटर्स का. अगर एक आईएसपी का राउटर, उससे तो लाखों कंपनीज एडेड रहती हैं.
हाँ.
तो फिर उस तरह से सर तो वो 1 लाख राउटिंग टेबल बना के रखेगा.
नहीं, लेकिन मुझे जो इंफॉर्मेशन मिलता है मेरा क्लाइंट से, उतने सारे राउट्स मुझे मिलते हैं.
हाँ.
अब एट द एंड ऑफ द डे राउटिंग टेबल क्रिएट करना तो जरूरत ही है.
ओके.
ठीक है, लेकिन हर राउटिंग टेबल में मैं लाखों की नेटवर्क सेव नहीं करता हूँ ना.
यस सर.
मेरे जो क्लाइंट्स की राउट्स होता है वो इतने सारे क्यों होता है ना.
यस सर.
मैक्सिमम 10, 20, 100 होता है, उससे ज्यादा तो होता ही नहीं.
जी.
ठीक है, लेकिन
Yes,
हाँ, अगर वर्चुअल राउटिंग टेबल क्रिएट करना है तो वो तो प्रोसेसिंग होता है, लेकिन मुझे जो मिलना है वो तो मिलेगा.
यस सर.
Yeah. So
यस सर.
using these VRFs, I will differentiate my clients, and I will extend those VRFs throughout my domain, where each and every router knows to which particular routing table do I receive this traffic, and according to that routing table, I will forward that traffic. Here, and if you see here, the same thing. Why do we need VRFs? Because let me think, I'm having company A and company B, and both of them, they are using networks 10.1.1.x, 10.2.2.x. Same with A and B component. Right? Now, this particular device or this particular router, a PC with the source IP 10.1.1.20 needs to speak with 10.2.2.20. Yeah, and his intention was actually to go to router B. Right. So he has sent the packet. The packet is received by the ISP router. But as ISP router is saving all the routing information in his global routing table, he cannot differentiate the customers. So he thinks whatever the route he receives, he don't have any identity. So he thinks that whether he's receiving from company A or company B, the route he thinks is all the same. Now 10.1.1.0 from company A, 10.1.1.x from company B, and the same from A and B. Right? Now he has received the information from two sources, 10.1.1.x from router A and from router C. Now what will he do is, the network is same, prefix length is same, and let me think it is a static routing, right? Or else we have learned it from RIP. And in whatever the case, my AD value is same. When my AD value is same, obviously I will go for metric. Now, okay, now RIP will not work in this case. Let us think EIGRP. Okay, AD value 90. Now my metric, according to my metric, Metro Ethernet will have better metric than the serial interface. So what will he do is, whenever the packet is received for the 10.1.1.x as a destination, he will forward it to the company A router. Now, if the traffic comes from router B, it goes to router A. And even if it comes from router D, which is intended to go to router C, because of this metric, he will forward it to company A. And this is bleaching. One router information, one company information has entered into another company. Right? And the same thing happens if when A needs to speak with router B 1022X.
So इसमें नहीं आया कैसे कर रहे हो?
Sorry?
So this is not clear means how.
अरे देखो,
Can you repeat it?
हाँ कुछ नहीं, देखो ये तो इथरनेट इंटरफेस है,
Right.
ये तो सीरियल इंटरफेस है.
ठीक.
ठीक है. अगर मान लो मैं EAGR पे चल रहा हूँ, मुझे एक ही नेटवर्क इंफॉर्मेशन 10.1.1.x 10.2.2.x दो कंपनी से मिला है, एक कंपनी ए एक कंपनी बी.
ठीक.
पहले हम 10.1.1.x पे चलेंगे.
ठीक.
Have got this information from two routers. One is from router A and one is from router C.
ठीक.
I'm learning it from EAGRP.
ठीक.
पहली चीज, prefix length is same for both networks.
ठीक.
I will go for AD value comparison. AD is also same, EAGRP 90. Now I will go for metric. According to metric, Metro Ethernet will have better metric because it is Ethernet interface. And from C to D, it is point to point. According to EAGRP, whoever has the better bandwidth, their cost will be low and their route will be installed. So here Metro Ethernet, this interface will be made best for 10.1.1.x network.
Right.
Okay. Same in the same way for 10.2.2.x, best will be interface 4 router D. ठीक है. अब देखो मेरा डेटा देखो. If 10.2.2.x router B needs to speak with 10.1.1.x, good, it is going to the intended person because of this. But if C wants to speak with if D wants to speak with 10.1.1.x, which is intended to router C, it is not going to him.
उसके लिए वो बेस्ट पाथ वो है बेस्ट.
ये बन गया तो यहाँ पे जा रहा है.
ओके.
ये तो गलत है.
बिल्कुल.
Right? And why did this all happen? Because ISP router is saving all the routing information in global routing table or in a single routing table. Right? In order to avoid this problem, we need VRFs. Now, how does this VRFs will solve this problem? Without VRF. Without VRF, the best path only will be this way. For 10.1.1.x, this path. For 10.2.2.x, this path. And these two links will always be unused. And if we go for VRF, with VRF, yeah, so the best path selection is applied. And upon doing it, the best path for 10.1.1.0/24 router A is the best. And for 10.2.2.0/24 router D is the best. And when I separate them with VRF, I will separation maintained via VRF to interface allocation. Now what will I do is VRF for company A, separate routing table for company A, separate routing table for company B. Upon doing this information will not mingle with this information and this information will not mingle with this information. Why? Because they are completely in separate routing tables. My router will not even try to compare them.
मतलब सर अगर राउटर ए अगर राउटर बी को पिंग करना चाहेगा तो वो बस कंपनी ए का ही करेगा, वो बी में नहीं जाएगा.
बिल्कुल नहीं जाएगा. That's what I'm saying. This routing information will be maintained separate based on the routing tables, which means that one VRF information cannot communicate with another VRF.
Okay, sir.
Here.
Yes, sir.
And now with this, whenever this C needs to speak with 10.2.2.x, it will go for router D. And whenever router D wants to speak with 10.1.1.x, because of this VRF, in this VRF, we have got only two networks, and that points to router C and router D. Now, there can be no case where router D can communicate with router A for network 10.1.1.x. And how did I achieve this? With the help of VRFs. Clear, bhai?
Yes, sir.
And at the point of when we are doing this, practically you will understand this very clear.
Okay, sir.
So, how do we configure these VRFs? First, we need to go for global routing configuration mode, and there we have to create the VRF. So what's the command to create VRF? IP VRF, and give some name to it, right? Such that you can identify it based on clients or whatever. Give the name, and with this, your VRF will be created, right? Now, what we need to do is we need to apply VRF to selected interfaces. Now, what does this mean? We need to make interfaces part of that particular routing table. Here, by default, whatever the interface or whatever the IP address you give on the interface, that will go and store in global routing table.
Yes, sir.
Right? This is because the interfaces, whatever you're attaching to router, they are by default part of global routing table.
Yes, sir.
Right? Now, I have got three interfaces, F0 by 0, F0 by 1, F0 by 2. Now, I want TCS to be part of VRF TCS, and I want BT to be part of VRF BT. Clear? So how will I do this? Basically is the interface that is connected to BT, I will make this interface F0 by 2 part of VRF BT. And the interface which is connected to TCS, that interface will be part of VRF TCS. Okay?
सर ये जितना भी VRF का कॉन्फ़िगरेशन होता है ये सारे ISP एंड पे होते हैं, क्लाइंट एंड पे नहीं?
नहीं, सिर्फ ISP एंड पे. ठीक है?
Yes, sir.
Now when I made this F0 by 1 part of this VRF TCS, whatever the information I'm receiving on that particular interface, whether the routing table information, whether the routing information, whether the data, everything I will do it according to the VRF TCS. Clear?
Yes, sir.
Yes, sir.
भाई देखो बाय डिफॉल्ट हमारे ना अब जो अभी हम राउटिंग प्रोटोकॉल चलाते हैं राउटर रेप राउटर EJRP राउटर OSPF, ठीक है, the information learned by that routing protocols is by default stored in global routing table because the interfaces by default they are part of global routing table. Clear?
Yes, sir.
Now when I made this interface part of VRF TCS, now whatever the information I learn it on this interface, I'll make it part of
VRF TCS.
And I'll make this part of VRF BT.
Yes, sir.
And whatever the data I am receiving on this particular interface, I will forward it according to the VRF TCS. Got the differentiation?
Yes, sir.
And this interface allocation is very important when you are creating a VRF. Okay, so everything is dependent on this interface allocation.